Standard form being that right there. So we remember all this stuff is right here. All the stuff that the standard form tells us automatically. This is what we worked on. Well, we didn't. You guys didn't work on it. We discussed it right here. And it gives us a new tool for graphing these things. So we already know about the y-intercept. We already know about what the a will do for us. And then we have two choices. If we factor or we quad formula, we get the roots. And we know the vertex has to be right in the middle. If we can't factor it and the quad formula is yucky, it doesn't give us nice numbers, then we can go to this move, this part of the quad formula, which gives us the value of the vector's x coordinate. The only problem with that, I just said the vector's x coordinate, didn't I? The vertex's x coordinate. The only problem with that is a vertex has two coordinates, yes? An x and a y. So you got to take that x and you got to remember to put it back in here. So what we're going to do here is you will notice that that one is a really good candidate for completing the square, yeah? What makes it so? It's got an even b and no number out front. So this one we can put right into vertex form, right? Super easy. That one's barfy. What are we going to do? We don't want to complete the square there. So we could either, now since we can't complete the square. Since we can't complete the square, we have to either factor or use the quadratic formula. Now if we use the quadratic formula there, just by looking at it, we know it's not going to be pretty. So this is a good one to use the negative b over 2a. This one, not bad for complete the square because it's got an even number, but it's also got a 3 out front. So you got to factor that 3 out. And a great many of you kind of screw that up, right? So maybe that one you want to consider this move again. I don't know. And then same with this one. It's almost exactly the same. So we're going to work through these 4, and then I'm going to give you your assignment. Is there like a late bus or something? Or can all of you just not tell time? This is when somebody answers me, because 20 people just walked in late. 21. There's warning bells for a reason, people. Next Monday, the door starts getting locked at 10 after. If you're not there, I'll let you in when I damn well feel like it, because you only feel like coming to class when you feel like it. Okay? So if you have a day 4, don't expect to be allowed in if you can't tell time. We've decided that one is a good one to do complete the square on. Remember f of x from grade 10? That's just a fancy way of writing y. So that's y plus 6, x squared plus 10x plus 25. So I add 25 to that side. Y plus 31 equals x plus 5 squared. Y equals x plus 5 squared minus 31. And then you would graph it. So you know the graph is at negative 5, negative 31. And you know that the y-intercept is negative 6, which makes that 0, negative 6, which means you've gone 5 away from there, so 5 away from here is negative 10, negative 6. And there's your graph. B is yucky. We're not going to complete the square. And it doesn't factor because there's no factors of 2 that equal 5. So what are we going to do? We're not going to do the whole quadratic formula because that's ugly. It'll take too long. we're going to use this move that we used last time because that equals the vertex of x. So I'm going to take that and take negative b, which is 5, vertex x equals negative 5. I'm going to write it all out. Negative 5 over 2 times 1, which is 5 over 2. Still difficult to work with because now x is a fraction, right? So it's still going to be a pain to work with. So I take that x and it's got to go back into the original equation to find the y right here. So vertex y, that should have been a different shade of blue. I wanted a different shade of blue. My vertex y has to be 5 halves squared minus 5 times 5 halves plus 2. And that gets me 25 over 4 minus 25 over 2 plus 2, which is 25 over 4 minus 50 over 4 plus 2, which is negative 25 over 4 plus 2, which is negative 17 fourths. And now I can graph it. I know that it's going through plus 2. I know that the vertex is 2.5 and negative 17 and quarters, which is 4 1/4. And since then I can put that right there, I know that is positive 2. And since this is 2.5, 5 halves, this must be 5. And I can make my graph. Nope, I've already used black. C. What are we going to do with C? Your choice. It is a good candidate for complete the square because that's even, but when you factor out that 3, you end up with 3 bracket something, and a great many of you forget that that 3 has to multiply by this when you add to the other side. So I'll wait. Somebody can give me what they would think we should do with that, and I'll do it that way. You want to complete the square? It's a smart move because that's what most of you need the practice in. So y equals 3x squared minus 6x plus 7. I always like to get rid of that 7 because it's not part of what I'm going to be working with. Y minus 7 equals 3x squared minus 2x. There is the trinomial that I am trying to work with. What is half of 2? 1 squared is 1. So how much have I added to the right side? Again, it's 3, but a great many of you I've seen in your work are only adding 1. It's 3 because there's a 3 there. Your a value is 3. So I've added 3, so y minus 4 equals 3x minus 1 squared. Y equals 3x minus 1 plus 4. And then, of course, it's easy to graph because we are at 1, 4, and we are going up by 3s, which makes sense because my first, y-intercept is 7, which is 0, 7, which means I moved 1 over here from 1, 4, and I went up 3 because I have an a value of 3. So this one right here, since that's 1, this is 1 away, that is 1 away. That makes this 2, 7. And then I can graph it. And lastly, what color haven't we used in a long time? We haven't used this light green, D. Now, since we just completed the square here with a factor, do you want me to do that again, or do you want to use this some more? Because this is a new thing. Use the new thing here. All right. So the new thing, we are dealing with y equals negative 2x squared plus 8x minus 3. The new thing is the vertex x value is negative b over 2a, which is negative 8 over negative 4, which is positive 2. Once I have the vx value, I can then go ahead and get the vy value. That should have been green. I can get the vy value because x is negative 2, so the vy is negative 2 times 2 squared plus 8 times 2 minus 3, which is, what is it? I'll let you practice some math. Negative what? Negative 8 plus 16 minus 3, which is 5. So now we know our vertex, and now we can graph it. Our vertex is 2, 5. Our y-intercept is negative 3, 0, oops, not 0, positive 3. Dummy head. Our vertex is 2, 5. And our y-intercept is 0, negative 3. That is 2 away. So I should have gone down 4, but because it's 2, I went down 8. So I got to go 4 away over here to get to 4, negative 3. And then I graph it. Everybody cool? You've got many tools to work with this form, yes? Do you have to be able to use them all? No. You can choose one and get real good at it. I don't really care. You can use quadratic formula for all of them, but remember, if your roots are weird, you gotta do this move right here. If the roots are weird. So page 108 and 109 have 14 questions. Remember, these are your tools. 1, complete the square. The instructions say complete the square, but I don't believe in forcing you to do so. I know most of you don't like completing the square, but if you still refuse to believe that it is the fastest thing to do in the right situation, then I'm never going to convince you. Right? It's like trying to convince Jacob that he doesn't need to expand that. It's impossible. It's never going to happen. I've been working on it for 2 years. So I'm not going to force you. If you're not going to complete the square, remember you have factoring. You have the quad form. And you have this new and rather powerful vertex x thing, which is just like an ugly cousin of the quadratic formula, right? They just work together. And you got those 2 pages to work on. It's 8:26. You have class until 9:30. Like I say, I have a little game that I like to play. It is effective for graphing, kinda, but I don't want to do that right now. And of course, it being Friday, I would have no problem playing a few of the word game things, but I won't be doing that until 9 o'clock. So you got 33 minutes of work time, please, on this stuff. So nobody can tell me on Monday that you didn't have time to get it done, because 33 minutes is enough time to do both of these pages if you actually work. Go.